So 2024 GCE Paper 2 question 11. A cuboid has a total surface area of 180 square centimeters and is such that its height h is h and its base is a square base of sides x. So the base is square. If this is x centimeters, then even this one will be x centimeters. So now show that the height h of the cuboid is given by this. So we can take advantage of this fact. We know that A, which is the total surface area, we normally just use the letter A, is equal to 180 square centimeters. And then at the same time, we know how to find the total surface area of the cuboid. You just find the area of this face and the area of that face. Since these two faces are the same, you can just put a 2 there and multiply the area of this face. So the area of this face is x times h plus the area of the base, which is x times x, let's just say x squared, and then plus the area of this face here, which will be x times h. Of course, the formula is this: 2u lb plus lh and then plus bh. The order doesn't really matter as long as you have found the area of each of the faces. You just need to find the area of 3 faces, multiply them by 2, then you have the total surface area. So our A is equal to 180. Let's forget about the units for now. And then we have a 2. We can simplify the letters in the brackets, the variables. This is actually this plus this will give us 2xh and then plus x squared. And then you can either expand or divide both sides by 2 to reduce the numbers. So I'll just expand. You can try to divide through by 2 and reduce your numbers. Then you realize that it will be much easier that way, but I don't want to lose anyone in the process. So now your job here is to make h the subject of the formula. Once you make h the subject of the formula, then you'll be able to show that h is actually equal to this. So I can take the 2x squared this side, then we have 4xh here. Then we can divide both sides by 4x, and then I'll write the h this side. H will be equal to this, 180 minus 2x squared over 4x. So because we didn't divide by 2, we have something that is a bit different but not really incorrect. So you have to reduce this fraction by factoring out a 2. Once you factor out a 2, you have a 90 there, and then you have an x squared here, and then you have 4x here. So 4x into, 2 into 4x will just give you 2x. Will give us 2x, and then we have 90 minus x squared over 2x, and you are done. You have shown that h is actually equal to 90 minus x squared over 2x. And then express the volume of the cuboid in terms of x. So to do that, the volume of a cuboid, or volume in general, is given by base area times height. So the base area here, since this is a square, the base area will be x squared, that is x times x. So we have x squared multiplied by h, like this. But then we want the volume in terms of x, not h and x. So to do that, since we know that h is equal to this thing here, I'm going to substitute this on the h. So I have 90 minus x squared over 2x, like this. And then I can reduce this. One of these two x's will be taken care of by this. So we have v is equal to this times this will be 90x. Then this times this will be x to the power 3 over 2. So that means you have expressed v in terms of x. And then hence determine as hx varies its maximum volume. So to find the maximum volume, you need to find the x values first. So to do that, you can differentiate this and equate it to 0. Remember, at the maximum point or at the minimum point, dy dx is always equal to 0. So let's quickly do that. I'll differentiate this with respect to x. But before I do that, let me just separate the numbers so that it's much easier for me. 90x over 2 minus, this one will be x cubed over 2. So now this is 45 x, and then this is like half x to the power 3. So now let's differentiate this with respect to x. dv dx will be 45 minus, this one will be 3 over 2x, and this power will reduce by 2. So now I'll solve for x. Remember, at the maximum point or the minimum point or the point of inflection, dy dx is always equal to 0. So you can even substitute this with a 0. So you have 45 minus 3 over 2x squared is equal to 0. So I'll take this one to the other side to minimize the number of negative numbers. And then at this point, I can just multiply both sides by 2 over 3. You can cross multiply if you want, but I think it's much easier this way. This times this, or maybe let's just do this. 3 into 4 is 1. Remember 1. 3 into this is 5, I think. Yeah, and then this times this will be a 30. Then this and this will go, this and that will also cancel out. So this times this is 30 is equal to x squared. So that means our x at the maximum point will be the square root of 30. So you don't need the negative part here because these are dimensions. We are talking about the length, the breadth, and the height. So now to find the maximum volume, you can simply use this x there. If you want, you can punch it on your calculator to find the approximate value, but I don't like that. So v is given by this. V is equal to, I can use this version of it, 45. Whether you use this or the first one, it's still the same. So v is equal to 45x minus half x cubed. So we can substitute the x value there, which is the square root of 30 minus half multiplied by 30 to the power 3. So now this is like 45 the square root of 30 minus, this is the same as, I don't know how I can explain this. Maybe let me just show my working. This is like 30 times 30 times 30. And then we know that 30 times 30 is 900. So we have 900 times 30. And then the square root of 900 is 30. So you can just write the 30 outside the brackets and 30 inside the brackets like this. So v will be equal to 45 root 30 minus half. This, like we said, or if you want, you can just expand everything like this, and then you separate them like this. This is true. So the square root of this is 30. This is how I'm getting 30, the square root of 30. And then we have 45, the square root of 30. Half of 30 is 15, the square root of 30. And then your v will be equal to, actually this is 30. Since these two are like terms, I can subtract. So this one will be 30, the square root of 30. And then you can either end it here, since we don't have any perfect square factors of 30. You can either end it here or punch it on your calculator and get an estimated value of this, which is 164.3168, and then finally you round it off correct to 3 significant figures without forgetting the units. Remember, we're dealing with centimeters, so this will be cubic centimeters. So if you don't want to work with these numbers, you can just punch this on your calculator. The answer will still be the same. Okay, this marks the end of this question.